Steam temperature of a boiler is critical for the safe, reliable, and efficient operation. The desired deviation range of the temperature is plus minus 4 degrees centigrade from the set point. Operating, tem operating the boiler outside of this temperature range can seriously affect safety and economics of the boiler and turbine operations. In this particular video, we will be knowing how the main steam temperature is controlled. What are the mechanism of this control? This is a very easy explanation. Just dive into it. So what happens is from the boiler steam is generated and goes through a series of superheater. And between the superheater, there are de-superheater. So superheater basically heats the steam and de-superheater cools the steam. Now this steam goes into the turbine for operating the turbine as the driving force for the turbine, and the steam can be used for other purposes in the plant also. That's why maintaining the temperature of the steam is very important for the proper operation of the turbine and other equipments in the plant. Now in the de-superheater, what happens basically, the water is sprayed through a control valve, and that is how the temperature goes down. Now controlling this temperature is very important. Here I am going to explain the most common scheme available for controlling this temperature. Now this temperature, main steam temperature, is sensed by a temperature transmitter, and then the signal goes to a temperature controller. This temperature controller is known as the main steam temperature controller, and the TT, which is sensing the temperature, is known as the main steam temperature transmitter. Now this controller receives the set point by the operator, right? And further, the output of this particular temperature controller goes to another controller, which is known as the secondary controller. This secondary controller receives input from the outlet of the de-superheated temperature and compares it with the set point it received from the TC1. And then final manipulated variable goes to the control valve. So what happens here is basically first there are two loops here. As you can see, this is a cascade control, and there are two loops basically. This is your secondary loop, and the other one, this one is the primary loop, right? So this one is the primary loop, and we can say this TC1 is your primary controller and TC2 is your secondary controller. If we don't have this secondary controller, what will happen? This temperature increase in this temperature will take sufficient time, because there are lots of dead lag here. So if there is any changes in the spray control valve or the temperature of the spray water, which can affect the temperature of the main steam temperature, taking action for that will take very long time. That's why the secondary loop is constructed, and this loop is much more faster, because this temperature change can be easily detected by this temperature transmitter, and that gives the pressure variable to this particular controller. The output of the TC1 acts as a set point for the TC2, and this gives the manipulated variable, final manipulated variable to the spray control valve. For the TC1, this is your PV1, this main temperature, and this is your SB1, main temperature set point, and this output is manipulated variable. So this manipulated variable actually works as set point to the TC2. Okay, so this is how this temperature control works. Now, um, there are many other points to this temperature control, or many other improvement can be done to this control. One of the major point here is what is the change in the flow, right? Change in the steam flow can be a concern. So, uh, so for that, what can be done is basically we can take another flow meter here, and that flow meter signal, right, can be added to this controller as a feed forward control. So this is a feed forward. What will happen is if there is a change in the flow of the loop, right, this flow, if it changes, obviously temperature will change, but the change in temperature will take time. It will be first detected by the change in the flow. If we have a flow meter, that flow meter reading will change first. So if we can provide this input beforehand to the TC1, and this TC1 can add this change in the flow transmitter with their set point, then through a parameter, then it can compensate for the change in the temperature at the later stage. So it is like a forward looking, right? It is like a forward looking controller. So it anticipating change in the temperature, and based on that anticipation, it is uh, changing its output so that it can take action beforehand. So this kind of control is often employed. Another thing that is of the most concern here is this measurement. Temperature measurement is very critical. So we should always use the uh, proper temperature measurement techniques, and the temperature measurement should be having an overall accuracy of less than 1 degree centigrade, so that uh, overall loop can be maintained at least plus minus 4 degrees centigrade, because this is kind of a uh, this is kind of a rule to keep this temperature within the plus minus 4 degrees centigrade, because deviation from this temperature range may impact your safety and economics of the boiler. So in summary, for the main steam temperature controller, main steam temperature control, there is basically a cascade control. Cascade control, there are two loops. One is primary, another is secondary. Secondary loop constitutes of the temperature transmitter uh, at the outlet of the superheater and the temperature controller. And the primary loop constitutes of the main steam temperature and the controller. The primary controller uh, can get additional information from the flow transmitter, main steam flow, and that can act as a feed forward to it. So overall, this combination of cascade and feed forward can provide a good amount of accuracy to the loop. Hope you understood the concept of main steam temperature control.